Hello all, today in this video I'm going to show an Python code implementation with a different kernel which is linear kernel, and the code is a machine learning algorithm which is support vector machine. Previously in this channel we have put the code demo for this support vector machine, that is SVM, but we didn't do any kernel functions. So the next simultaneous videos will be regarding the support vector machine kernel functions, and in this video I'm just showing the linear kernel function. So in a video in a Python code, so the first step we will do will be importing the libraries. So the libraries which we are going to use in this code are pandas, then sklearn. From sklearn we are just importing train, test split, and also svc library. Since we are using SVM code, we are using SVC library. So if you are using some random forest or naive base, means we will be importing that specific library. So now we can just run this library function. You can see down the library is implemented. Then I'm just calling the iris csv code. So already in this file I'm just having this iris.csv. So I have just called it using the read csv file. Why I'm using read underscore csv means since our out input is a csv file, .csv file, I'm just using the pd and read underscore csv by using the pandas, that is a pd file. So now I'm also the loading the iris data set. Then we have to split this data set into x train, y train, x test, and y test. So in order to split the data set, I'm just using the sklearn library, which is train, test, and split. From that I'm just using the test size of 1, which is the test size is 10% and the training size is 90%. So generally we will be using 2, since if it so means the test percentage will be 20 and the training percentage will be uh, 80. So if you want some other means, you can just change the test size. In this code I'm just giving as 0.2, since I need 20% for testing and 80% for training. So in the x label I'm just calling the features of the data set, and in the y label I'm calling the other date feature which is to be classified. So I'm just running this train, test, split, and the classification of this data set. So now it is run. So the next code, next line we have to do is to fit, that is train and test our SVM model with the kernel, linear kernel. So in the SVM, in the previous model, if you see means we would have called only SVC off, and in that off we have not declared any function since we have not used any kernel. So in this code we are just going to use some kernel. So to use the kernel linear, I'm just calling a variable c and also a gamma variable along with this. Then I'm just using training the model by using the fit function, and to train the model I am calling the variables like the x train and the y train. Then I am testing the model and just calling this variable testing variable in an variable called y underscore pred, and this y underscore pred we will be using to display the performance metrics graphs. So by using this predict function we are just testing the code. So then by using the test functions we are just displaying the accuracy. You can see our accuracy is 1%. Then I'm just running the code. It's 1%. So then after this we are just displaying the metrics of the as algorithm, that is support vector machine. So for that, in order to metrics, I am just calling a library from sklearn, which is metrics. So from metrics, I am just calling the classification report. In that, I am just going to display the values of y test and the prediction, that is the testing value we obtain. So while we are running this, we will get the values of the performance metrics like precision, recall, and F1 score. Nearly we are getting 100% accuracy. 1 means 100%, so 0.99 means 99%. So why I'm just calling with kernel means, previously in the support vector mission itself we got the maximum 100%, but this is for iris dataset. For every dataset we won't get the same accuracy. So to work with the different data sets, if you're working with different kernel functions means, you can definitely see some variations in the accuracy, and also the other performance metrics functions such as precision, recall, and F1 score. So in the next video I will be just making the SVM code implementation with some other kernel, which is RDF. Thank you.